Okay, so the last section of your biochemistry is the 4 major organic biomolecules, and we're going to break these up into their 4 sections: carbohydrates, proteins, nucleic acids, and lipids. And so anything organic, all that means is that it contains carbon. So all of these have carbon in there, and really just the other Schnapps elements. So we're going to start with carbohydrates. And one thing I do want to point out on after reading some of the reviews that y'all sent in, my videos take way too long to download if I talk slowly, so that's what rewind and pause is for. So just use that as you need to, but I can't slow down because it just takes way too long for these to download. So come see me if you need clarity, or rewind me and replay it, okay? So carbohydrate. Carbo tells you that carbon is in the, it's in the molecule, and then hydro means water. So you have carbon, hydrogen, and oxygen, and those are actually in a 1 to 2 to 1 ratio, just like C, H2O. So you have 1 C, 2 H's, and 1 oxygen. And something to watch for when I ask you, when I just give you a picture of something and I say, what is this? These tend to form carbon rings. We're going to draw some down below, so you'll see what those look like here in just a few minutes. So sugars, starches, things that end in ose, these are going to be the molecules that are carbohydrates. We use these for cellular energy. If you'll remember from biology that we did cellular respiration, where we took glucose from photosynthesis and we broke it down in the mitochondria and created ATP. So that's where we take glucose, and then so that is a carbohydrate, and we use that for cellular energy. So we're going to look at 3 types. Let me get to the end of that. There we go. Okay, so monosaccharide, the word part mono means one, and sacchara, or however you say that, it means sweet. So it's 1 sugar. These are the monomers of complex carbohydrates. They can be the whole molecule, like ribose, the sugar of RNA, deoxyribose, the sugar of DNA, fructose, glucose, galactose. Those are all monosaccharides. So they are a single ring. So I'll just kind of... You did a gizmo, dehydration synthesis gizmo, where you had to create a glucose, and that is a horrible ring right there. But that's, what you're looking for, a carbon ring with hydrogens and OH groups on it. That one's oxygen. So you don't have to draw that. We're going to draw that here in just a minute together. So, but that is a monosaccharide, just 1 ring by itself. Okay, a second type is a disaccharide. So table sugar is an example of that. Di, you learned in biology, means 2. Sacchara is sweet, so it's 2 sweets stuck together. Table sugar, which is sucrose, is glucose and fructose stuck together. So when we break that down, we get those 2 monosaccharides. And then the last one is a polysaccharide. And I'm going to keep this bottom hidden because we're going to draw it together. So a polysaccharide is many. Poly means many. So it's very complex sugar. Starch, which you find in potatoes, is an example of this. It's a very common example of a polysaccharide. And so we're going to draw starch. And I'm actually going to just draw it right here. So underneath your writing, you're going to draw this picture right here. So from a distance, starch is hundreds or thousands of monosaccharides stuck together. So just draw a button, and you can just take a marker and make dots. I don't have a marker sitting right here with me. Just some branches. These are all monosaccharides. individually, and they're all linked together through covalent bonding. I also know that the bonding is going to be this sugars can dissolve in water, so it's going to be a polar covalent. Okay, so then if we took this, and you just, kind of draw a few, and we zoom in on it. We zoom in on like one little part. Okay? Then you can see that these are glucose just stuck together. So the way you would draw glucose is just draw a line and put oxygen right here. Do like that. And with chemistry, anytime you see a ring and there's nothing on the corners, it is always assumed that that's a carbon. So these are carbon rings with carbons on each corner. And because this is making a bond somewhere down here, like hundreds of times, we're just going to kind of do that. So that's the OH group that is bonding with another molecule. And so this OH group that would be here is now making a bond with another glucose. And that's how they get stuck together. So this is a line. Oops, sorry. Ignore that. Put your oxygen in the corner. That's the one corner that has oxygen. It's the exact same thing. And then it just keeps going. Okay, so that is if you're zooming in and looking at one of these polysaccharides up close, you can see that they're just the monosaccharides linked together through different bonds. So that's all on carbohydrates. The next video will be proteins.